Going on now to the last section of Chapter 7, Section 8, Complex Numbers. Well, we'll talk about imaginary and complex numbers, addition and subtraction, multiplication, conjugates and division, and powers of I. Negative numbers do not have square roots in the real number system. We've always said the square root of a -2 is not a real number. However, a larger number system that contains the real number system is designed so that negative numbers do have square roots. Now, the number system we've studied so far is called real number systems. This next level, larger number system is called the complex number system. And it will allow us to solve equations like this: x squared plus 1 equals 0. The complex number system makes use of the lowercase letter I, a number that is defined by definition as the square root of -1. So the number I is the unique number which will represent the square root of -1. This is often thought of when they first developed this as an imaginary number. But it's just a number that's not a real number. It's a complex number, as we will see. We can now define the square root of a negative number as follows. The square root of -p is equal to, we're going to divide this into two parts, the square root of -1 times the square root of p. And we said the square root of -1 is I, the square root of p. Now it's often written this way so that we don't get confused when we put the I after the p. The I is not under the radical sign. It ends right there. So by putting the I in front, it saves us having to make that error. And that's for any positive number p. So let's express this in terms of I. So in example A, we're going to take the -9, and separate it as to -1 times 9. We said the square root of -1 now is I. The square root of 9 is 3. So I3, or 3I. If there's no radical sign, we usually put the letter I after the number. And here, notice it's negative. So we have negative, then the square root of this, which can divide into -1. And then 48, we're looking to find a perfect square if there is a perfect square factor, and it's there is 16. So we have a negative outside. We take out the square root of -1. Then we have the square root of 16 and the square root of 3. The square root of -1 is -I. Square root of 16 is 4. And we have this. So again, we usually put the I after the number, and that's where we get this answer. Okay, I'd write this out, but this was, I think, pretty clear. Imaginary numbers. An imaginary number, by definition, is a number that can be written in the form of A plus BI. This is called the standard form of complex numbers where a and b are real numbers and b cannot equal 0. Because if b is 0, this is just a real number. So the union of the set of all imaginary numbers and the set of all real numbers is the set of all complex numbers. A complex number is any number that can be written in the form of a plus bi. Again, that's the standard form, where a and b are real numbers. Note that a and b both can be 0. So here are all example of imaginary numbers. Again, this is a plus bi. So this is really the super standard one. Here we would think of that's a complex number. Here we used to, at least I used to think of this as an imaginary number. This was a real number, and this is a real number. So that they're classifying them as imaginary numbers, again, I'm not too familiar with that, but we'll go along with what they say here. So here we see now a breakdown of all of our numbers in the complex number system. So on this side we have real numbers. On this side we have imaginary numbers. Notice these have the letter I in there somewhere. Here we don't see any I's at all on this side. Although if b is 0, then this I is 0, so that would be a real number. That's what I had mentioned before. Okay, I'm not sure how much your professor will ask you to remember about all of this. The key, of course, is real numbers are on this side, imaginary, and then this is the standard form of complex numbers. Now, the nice part about it in regard to these complex numbers is that we add and subtract them exactly the same way as we do algebra. We think of the I as if it were a letter. Everything's the same. So when we go to add these, we're just going to add the 3 and the 7 and get a 10. We're going to add the 2i and the 8i and get a 10i. And when we subtract, now notice we have to make this a negative, and the opposite of a positive makes this a negative as well. So we have a 10 and a negative 9 is a 1, a negative 2i, and now this becomes a negative I as we change the sign, is a negative 3i. So there's A, and again they're showing you how you change them around, and there's your B. Now when we multiply, we have a problem. It says to multiply the square root of negative numbers, we first express them in terms of I. For example, negative 6 and a negative 5 becomes a negative 1 times negative 6, negative 1 times 5. So this is going to be I, the square root of 6, I, the square root of 5. So now we multiply the i's, and we get I squared. And the 6 times 5, we get the 30. Now, I didn't stress this before, but this is very, very important. I is equal to the square root of -1. I squared, by definition, is equal to -1. So whenever we come across an I squared, that we have to replace with a -1. So this I squared here is a -1. And again, we don't write the 1 usually, and it would be given as that. This dot here is just a period at the end of a sentence here. Okay, so remember, when we have something like this is going to be I, the square root of 3, I, the square root of 5, which will give us I squared, the square root of 15. So there's an I squared out here that makes this a negative square root of 15. So keep that in mind. That's a big thing also. So let's work these out. I haven't been working them out. We've been moving right along here. Let's see if I can get a pen going. There's a pen. Right over here. Okay, so this is going to be I, the square root of 2, times I, the square root of 10, which will equal I squared, the square root of 20. I squared is a -1, so this equals negative the square root of 20. Now, keep in mind the square root of 20 is also the square root of 4 times the square root of 5. So this would eventually become -2 the square root of 5. Oh, I see I had a little pop-up on my computer there. Okay, let's do the distribution rule here. This is going to be 10I, and this is going to be positive 6I squared. But we know I squared is a -1. So this would equal then 10I minus 6. Now you might think that's a good answer. It is good, but it's not in standard form. Remember, standard form was A plus BI. So we have to switch that around and call that -6 plus 10I. There we go. And here we're going to FOIL 8. My outers are a -6I, positive 4I, -2I. For my middle term, there's positive 4, -6, and then my last will be a -3I squared. But what did we say I squared was? A -1. So this is going to become 8 minus 2I plus 3. Because this is a -1. A -3 times -1 is a positive 3. And here we have like terms. So 8 and 3 is 11 minus 2I. That now is in standard form, A plus BI. Okay, let's see what they show us now here. Okay, and they did simplify this. Took out the square root of 4 here, times the square root of 5. Square root of 4 is 2, and I squared was a -1. Okay, that's good. And then there's B, And there's my I squared there, which is a -1. And they have it like so. But they do convert this. Oh, busy time. There's a phone call. All right. They do convert this to standard form. That's why they are switching these positions. And then when we FOIL, there's my outers, there's my inners, there's my last term, there's a -1 here, I squared. This is going to become a +3. They combine like terms, add these together, and that's now in standard form. Okay, conjugates. We mentioned this a little while ago. And division. Conjugates are used when dividing complex numbers. The procedure is much like what we use to rationalize denominators. So we're going to be looking at what is a conjugate now of a complex number. Well, if this is our regular part, the conjugate of this is, again, the same terms, but a negative now. Okay, so this is the conjugate of this, and this is the conjugate of that. And let's see it in action here. So I may have lost my pens there for a moment. Okay, so find the conjugate of each number. So this is what we have. So the conjugate of this would be 4 minus 3i. And the conjugate of this would be -6 plus 9i. And the conjugate of I is just a -i. Okay, that was pretty easy. Okay, now we are going to do some foiling. And these are conjugates. And watch what happens. So remember, there's no middle term. They cancel out. So this is going to be 36. This is going to be a -64 I squared. But what is I squared? I squared is a -1. So this becomes -64 times -1, a +64. So this becomes 100. Wow, that's cool. And you're writing that out very well. Okay, now when we do division here, it's sort of like simplifying these fractions. What we use in our denominator is we will use the conjugate. Now remember, we're multiplying it by 1 in the form of -i over -i. So our denominator is going to become -I squared, and our numerator becomes a -3i and a -2i squared. But what is I squared? This is going to become a -3i, and this is going to be plus 2. -1 times -2 is plus 2 over -I squared. I squared is -1. The opposite of a -1 makes this a 1. And you might say, well, that's the answer. Well, in a way, it's the start of it. It's just not in standard form. So the answer then is 2 minus 3i. And we don't put it over 1. Now for this one, we're going to use the conjugate of the denominator, which is 2 plus 3i, 2 plus 3i. So our denominator is going to be 4 minus 9i squared. But what did we say I squared was? A negative 1. So this becomes a positive 9. So our denominator now is 13. And we've done that. Now we have to FOIL the top. This is going to be 8 plus 12, 14i, plus 3i squared. As I FOIL that, let me just check it all. 12, 2, 3, yes. But now keep in mind, I squared is a negative 1, so this is negative 3, and 8 become a 5, plus 14i. And you might think, well, that's a good answer there. Well, it's the start of it. You have to put it in standard form. So we have to write this separately. 5 over 13 plus 14i over 13. Now, if I were doing a paper test, I probably wouldn't take off for that. But in Math Lab, they want it to be in this form. You have to separate them. Okay, let's check it out here. Now, here they should be multiplying that by a negative I. I don't see that negative I there. Okay, I think they're making an error here, but little errors are not too bad. Because when you do the division, it straightens out anyway. Okay, here they are doing by the proper conjugate. And the bottom here, this will become a negative 1, so that's 13, yep. And they are separating it like they should. That's the proper form. Okay, powers of I, and I want to give you a little background on this. Now, as we look at powers of I equals I. Okay. I squared, we know, equals negative 1. I to the third equals I to the first times I to the second, which is negative 1 times I, which is negative I. I to the fourth is I squared times I squared, negative 1 times negative 1, which is a 1. So for every 4 powers of I, you keep getting the same pattern again, because this is actually I to the fourth times I, which is going to be 1 times I is I. This is 1 times I to the fourth, I to the second. I to the second is negative 1. 1 times negative 1 is negative 1. And then it repeats. This is going to be negative I, and this is going to be 1. So this is the pattern of how we deal with powers of I. So when we see something like this, what we mentally should do is say I to the 20th power times I to the third power. Now notice this is divisible by 4. This is going to be like I to the fourth raised to the fifth. That's I to the 20th. I to the fourth is 1. 1 to the fifth is 1. So what's left over? Well, I to the third. So this is going to be a 1 times I to the third, which is negative I. So 1 times negative I is negative I. And that's what they're showing you here. Okay? When you have even, for every fourth power of I that comes out of any exponent, those are all ones, as we show here. Then whatever's left is going to be one of these. So let's take a look at what they give us here. So I to the 40, that's divisible by 4. So this is just going to equal 1. Now for I to the 33rd, well, we got I to the 32 times I to the 32, this is divisible by 4, and that's just going to be 1. So all of this is going to be just I. They're doing it a little different way, but that's fine. 1 and I. Okay? And that wraps this up. Well, good luck on your test on chapter 7. We'll be doing chapter 8 next.